Hi guys, I'm Kerren Ortlepp, and today I'm going to do a talk on Kubernetes and Docker and how we use it in our dev environment. So we're a small startup company, we've got a couple of guys, and basically we use Docker and Kubernetes on a day-to-day basis. So today I'm going to just I'll quickly give an overview of what I'm going to talk about. I'm going to talk about Docker, what it is. I'm not going to go into too much of the technical details, but I'll talk about where we use it, practical applications, and then kind of show the limitations with Docker and how Kubernetes solves those limitations, and it actually lets us take our applications to the next level. So first, we're going to just kick it off with Docker. And when we look online and we ask what Docker is, a lot of people say that it's a container engine, and they say it's not a virtual machine. But we don't really, that's not a great explanation, because like, what is the difference between a container engine and a virtual machine? So I made a little diagram. So we've got virtual machines and Docker, and we know that the base components are the same on both. You're using your laptop or a server, you've got CPU, you've got RAM, and for a virtual machine, what happens is you've got your operating system, and then you've got what's known as a hypervisor. So a hypervisor is effectively drivers for your virtual machine to communicate with your CPU and RAM. And then on top of that, you install a guest operating system. And then inside the guest operating system, you install your applications. So there's a lot of overhead because you're actually installing pretty much an operating system in your operating system. So you've got a laptop in your laptop. So every single time you want to run this application, you effectively are starting up a whole laptop just to run the application. So startup times for a virtual machine are seconds to minutes. When you look at Docker, what they do is they let the operating system do the heavy lifting. So with your Linux, your Windows and stuff, it already communicates with your CPU and RAM. So they utilize all of this communication and all of the handling of these hardware components, and they've effectively abstracted that and made it the same on a Linux PC, a Windows PC, any operating system, Mac as well. So you got a Docker engine, and then on top of that, when you want to run your application, you use the Docker engine to run that application. So the way that we think of that is, instead of starting up a whole guest operating system on your operating system, with Docker, you're almost just running a program. So, okay, so that's basically... Sure, go for it.
We'll have a prize for whoever raises the speaker.
Is it going to be you?
No, I think I'm exempt.
Okay.
That's not true, right? Because most of the time, you're running Docker inside of VM.
Okay, that is true.
I mean, who's running Docker on bare metal?
On our dev environments, we do, but then also with Kubernetes, which we'll get to now, if you're running a bare metal Kubernetes cluster, then you would be using it on bare metal as well. So you are right, but there are cases when we use it on a bare metal system as well, and that's where Docker is super fast. So that's the difference. That's the difference between Docker and a virtual machine. And now, just before we continue, I just want to go into a bit of the terminology that you use with Docker. So with Docker, you get images and containers. That's what you hear a lot when people talk about Docker. So there's a difference between the two. An image is kind of like the code for a program, and a container is when that program's running. That's kind of how you can imagine it. So an image will hold your files and the libraries and the binary files that need to run your stuff. And then whenever you start that up and create a container that's using the image, you create a container of an image. So you can have one image, but multiple containers. That's effectively how you can imagine it. So throughout the talk, I'll mention containers all the time. I'm talking about these things where they're actually running your code.
So doesn't your image usually have an OS inside of it?
So the base Docker image, which I'll get to in a little bit, is usually based off an operating system, yeah. But I'll get to that now. So with Docker, there are quite a few benefits that you get. The first thing is the startup times. So as we mentioned before, you have a virtual machine, you have to start it up, and it has to make sure that everything's, the drivers are all set up and running. Whereas with Docker, you are effectively just starting a program. So it's a lot faster to start up a Docker container than a virtual machine. And that's actually leading to, with applications, we sometimes use Docker containers within a request. So a person might make a request to a server. We then start up a Docker container, do some sort of processing, return a result, and return that to the user. So it's changing the mindsets quite a lot because Docker lets us do some pretty cool stuff with containerization. Another thing that Docker lets us do is lock dependencies. So we might find that version 1.7 of some library that we use is what we need. And they've just updated to 1.8, and that doesn't work on our system anymore because they've changed kind of the function calls and stuff that we need. So using Docker, we can lock version 1.7, and we'll use 1.7. And whenever we pull down that Docker image with version 1.7, it will always be 1.7. So dependency locking is very important, especially for production-level servers. The final thing that I think we kind of underplay is the fact that we can run the same application on a server multiple times. So you might have an app that you're running, and if you imagine a server has 65,000 ports, and if you install this app on your server directly, you're going to find that it might want to bind to port 8080, and that's it. So if you want to start another instance of that app, maybe you've got a new client and you want them to be completely separate, it's going to also want to connect to port 8080. So now all of a sudden you've got to go into config files, and you've got to change those up so that when you start it up, it binds to a different port. Docker kind of lets you move away from that because you could install the app inside a Docker container, and you can bind Docker ports to any port on your server. So the first time you start up this app, it's got a Docker container port of 8080, and you bind that to your server port 8080. The next time you start it up, you use the Docker container port 8080, but now you bind it to 8081. So all of a sudden, you don't have to change anything in the installation of the app. You can build that the same way every single time. And that's actually quite important because a lot of the time when you're running an application, developers have written it to run in a specific way, and you don't really want to be messing around in the config files and changing stuff. It doesn't always work. So we can kind of remove that complexity and just bind ports across to your main computer, your main server. Cool. So a couple of applications where we use it in our business today. The first thing is the fact that half of the guys that develop in our company have Windows, and the other half I installed their laptops so they have Linux. So we've got two different systems, and when you install Node and all of those things, sometimes it's quite hard to get Node this version on Windows and on Linux. But if you use a Docker image that has Node version 8.1.2 on your Windows system and your Linux system, you know that those are the same version. So effectively, if you can get a Docker container to run on your computer, you can get a Docker container to run on anyone's computer that has Docker. Yeah.
Are you doing your development inside Docker containers?
Well, it depends. No, we kind of just use Node, and then we'll bind it to a folder or whatever like that. Yeah. Cool. But we can get into that a little bit later because that's very important, especially for development. If you're doing it in a local environment, it does help out a lot. So one of the problems that we have when you are doing development in a local environment is cross-origin resource sharing. I don't know how many of you guys have experienced this problem. Cool. Yeah, cool. I'm glad that a lot of people have put up their hand because it really, really annoys like anyone that's developing, because a lot of the time, CORS doesn't hit you when you're just doing basic development, but you use some other person's library and suddenly it doesn't work. And when you open up console 5 hours later, you realize that it was because CORS is causing this thing to crash. So to give a quick summary of what CORS is, CORS prevents calls that come into your server from a different URL or address. It basically just makes sure that your front end and your back end are from the same, or going to the same address, and you're speaking to from the front end and back end on the same path. And the reason for that is that you don't kind of want someone to maybe make Google1.com that chats to Google.com but does extra stuff. I think that's kind of a good explanation. I don't know if okay.
It's in the browser.
Yeah. Yeah. So your browser is trying to make it more secure so that you're not doing these requests to different URLs that maybe someone is fishing for information or something like that. So they shut it down. And when you're doing local development, now that we have front-end frameworks like React and Angular and stuff like that, a lot of the time we can actually build that into a distribution folder, and we can serve that up. And it has its own routing mechanisms and everything. So we don't really want to tie that to a backend. We kind of want a backend API and a front-end system. So all of a sudden, we've got front-end, which is on port 4200, and backend, which is on port 1337. And when they start communicating with each other, we sometimes get these cause issues, and our apps don't work correctly. So, yeah.
Yeah, could you just saw that? Because I've seen if you just check out a plugin one.
Yeah, so you can use a plugin. For those of you, so you can just put an extension on and turn off cause, but then if you forget to turn that off, suddenly F&B's website doesn't work for you anymore, and just the normal websites don't work because you've enabled cause, and some sites don't like that. But there's a very, yeah?
In essence, cause has nothing to do with Docker itself, because you would have your backend server that's running within your Docker container take care of your code.
Yeah.
It doesn't relate directly to.
It doesn't, but it does relate to the ports. If you do have multiple Docker containers, one doing serving up your front end, one serving up your back end, and now you have connected to your front end Docker container, and you want to start doing API calls to the back end,
Sure.
that's when you'll start hitting issues.
You would get that with any sort of containerized, even if you have 2 VMs.
Yeah, 100%, and that's
It's your service responsibility to take care of your posts. So
yeah. Okay. Don't know why I have.
Snarkeeper. Your Chromecast disconnect. 45 minutes on repeat.
Must I Chromecast to desktop again?
Yeah.
Which one was it? The Chromecast Ultra? Not multi. Okay. Multi-purpose.
Sounds like we need a talk on Crossorigin resource or how to get money out of someone else's bank.
So you're 100% correct. This has nothing to do with Docker itself, but there is a solution where you can use Docker to solve it very easily on your laptop or on whatever computer you're developing on. What you can do is make a little Nginx proxy above everything. And this proxy now accepts any traffic coming in for backend or frontend, and then it routes it to the correct ports. So instead of now bundling your backend and frontend systems together, you can instead route traffic. Anything that has a /API can go to your backend system, and anything that has your dashboard or not /API can go to your frontend system. So is that?
sorry, I have to mention one more thing.
Sure, go for it.
If you like deploying, for instance, just for an example, on AWS, so you would have a gateway that does that.
Yeah.
But on a local machine, you shouldn't add that extra layer of complexity when you're developing, because it's almost now you have to now configure proxy and you have to manage it, etc. In essence, like I said earlier, the backend server itself should have configuration in it to take care of your code. So you eliminate that layer. What you're creating here on your development environment is an extra hop, unnecessary.
Okay. That is fair. I think, though, if you do it this way, you can separate having to change a lot of backend configurations. You could just start up a Docker node container and another one for your front end and root.
Your backend Docker is essentially what's going to be deployed live. So then
Yeah.
you already have the configuration to take care of codes anyway.
Yeah, but when you deploy live, you've got a domain that you're referring to, so this cause issue goes away completely. So I'm just saying for local development, you don't really have a www dot that you're going to for your front end and back end system.
But that's when what I do personally on my local development is I try to give actual name domains to my local websites or whatever I'm running, and that way I mimic my local environment to as it would behave on the live environment.
100%, yeah.
It's guaranteed to work without.
Yeah. So you can definitely do that. This is just another solution to that. It's relatively quick to set it up because you just Docker run that image, and now you've got this proxy that's already sorting out all your cause issues. So it's one of those things. Definitely, that's another way of doing it. This is just a quick way that we use. Just a couple of other example containers that you can get from Docker: Postgres, Mongo, Redis, all of your different databases. You've got Node, you've got Nginx, and the one that's really quite special, and this was from that previous question, is that you can get an Ubuntu base, and then you can install something like Supervisor, which is basically it just monitors processes, and if they die, it starts it up again. And the way that Docker works is it latches onto a process and makes sure that that's running. And as soon as that dies, the container stops as well. So Supervisor will run, and it will make sure your stuff is running, and then Docker watches Supervisor, which won't die. And so this thing is running. So what you can do with Ubuntu and Supervisor is you can effectively make any kind of Docker container you want. You can install any libraries you want. You can make whatever backend system you want inside a Docker container. Okay, cool. So that's kind of where Docker comes in. What a lot of people get intimidated with is just running a Docker container. So the command is really, really long. And I think that kind of scares people into not using it because they open up a tutorial and it's a 2-line long command. But I'm just going to quickly run through what this run command actually does. And then from that, I think you'll see the value in each line. So the first thing is the name. The name of the container, you can either give a name or it will automatically generate one for you. Using that name, you can do stuff like kill the container. You can start it up again. You can check out logs. There are a lot of things that you can do with the name. So that's quite important to give a Docker container a name. The next thing, -e, that's for binding environment variables. So if a Docker image can be pulled down from anyone online, then you don't really want to put your passwords and your API keys and all of that stuff inside the container. Because if someone pulls down that, or inside the image, because if someone pulls down that image, they're going to have all of your username and passwords. So instead of sending that in the image, you can just bind it using environmental variables, or on the next line, you can bind it using volumes. So you can bind volumes, which is files or directories, into a Docker container from your host PC. So for example, a config file, you might have a config file set up that you want to bind into the Docker container, or you could bind a folder where maybe you bind your /temp directory to the logs folder inside Docker. Now, whenever your Docker container writes to the logs directory, it actually writes to your /temp directory inside on your laptop, and you can go in there and you can clear that out every 10 days, and you can read those logs and all of that stuff. And it's not if your Docker container dies, you don't lose your logs. -p is port binding. So you bind a port on the left-hand side is your host computer, and on the right-hand side is the Docker container. So in this case, I'm binding port 5432, which is Postgres's normal port, to port 18,000 on my laptop or on my system, which is really useful because maybe I've got a Postgres server that's running on 5432 on my laptop, and I want to start up another one quickly for a different development project. You can just bind it to that different port. And finally, -d is for daemon mode. Okay, so this is how you would run a Docker container. What about if we wanted to create our own? That's when we use a Docker file. So a Docker file, you specify where you're getting, from what Docker file you're basing this off, the base image, and then you can do whatever you want inside it. So I'll run through a couple of commands that you can do in Docker files. There's a lot more to it. The first thing is the run command. This is kind of like normal Linux terminal. So you can do apt-get, and you can make directories, and you can delete stuff and move stuff around. Expose is exposing a port inside your Docker container that you might want to bind to. Okay, hold on. Okay. Copy. You can copy a file from your host computer into your Docker container. And then when you just do a copy from your host directory into a Docker container, it's quite cool. It's kind of like you get a git ignore. It's called a Docker ignore. And you can ignore stuff like your dist folder. So you might not want to copy across a dist folder, but you do want to copy across your source so you can build it inside the Docker image. So copy. And then entry points and command are kind of misunderstood concepts. Entry point is the binary that gets called, and command is the stuff that comes after the binary. You can overwrite the command when you do a Docker run. So this is kind of like, if you don't write anything, it will use the stuff that you've specified there, but if you do write stuff, then it will overwrite the command with the other information you want to put there, which can be useful in some cases. Okay, so that's Docker. So let's now look at kind of a practical example of a system that maybe you'd want to build one day. Let's say you wanted to run a competition. You wanted to put an advert on Facebook. People would click the link. It would take this person to your site. They would put in their email. They click enter. It then goes to a little email sender and sends them an email. They go onto that email, click a link, and it brings them to a waiting room where they've entered the competition. Now you've validated that they're a real user because they've received the email and they've followed that link. And let's just look at the email sender. Let's say that your sender, you've written it, it's a special sender that you've made where it doesn't spam a person or only ever send an email once to them, and it maybe takes about 3 seconds to send an email. So that's pretty chilled, right? Like that's not a bad sender. Well, actually, because we've got about 525,600 minutes in the year, so you've got a lot of time that you could make these 3-second sends. This is all cool, but when we look at the application of what we were doing, we were going to run a competition. Most of the time, you're going to have a huge influx of users in a very short period of time. And then when you're not running the competition, you won't have anyone, right? So if we have let's say 100 users want to enter this competition, and they all go to your site in one go, they all click send, and that means that 300 seconds is how long it will take for the last person to get an email, if this was serial. So I don't know about you guys, but when I log into email, after about 2 seconds, if I don't get in, I'm like, well, my internet's down. There's something wrong. So you can imagine if it's taken 5 minutes to get through to someone, they probably completely changed what they're doing, and they've forgotten about your competition. So what's the solution? Well, you could either rewrite your code and try to make it a lot faster, but sometimes there are things that block it from going any faster. Or maybe you could just make a lot of these senders. If you have 100 people that need an email and you have 100 senders, it's going to take 3 seconds for all of them because it will use a different sender for each, right? So we've got 100 senders. But now you've got from port 10,000 to 10,100, you've got to send on each. So whenever you want to send an email, you've got to know which port to go to and send traffic to each one of these senders. That gets a little bit complicated, so we install a load balancer, and you specify it's from port 10,000 to 10,100. Now we've got our system set up, right? But then if we add another 100 senders, we have to go back to the load balancer, change the configuration, and it's kind of like a manual process. And that's where Kubernetes comes in. So now we've seen that Docker, we can use it, and we can make all of these senders, which is really, really useful. The next step is to introduce Kubernetes. So before I get into how we would use it in this application, I'll just talk about what it is. So Kubernetes is a container platform. What that is it effectively takes a lot of containers and wraps it up into a system. And those containers can communicate with each other, and there's a lot that Kubernetes does around that. Google Cloud uses Kubernetes by default, so if you start up a Google Cloud cluster, you've got Kubernetes on that. One of the really important things is that it will make sure that your system is running, and if some of your containers die, it will restart them automatically. So you don't have to start getting emails at 2 a.m. in the morning saying that your system is no longer receiving requests or something, and you have to log in and restart anything. It will do that for you automatically. And Kubernetes is kind of, the way that I look at it is it's kind of a language that you need to get into. So once you understand the language, it's actually quite easy to apply. So let's take a look at, in the previous example with the load balancer and all those senders, what the terminology would be if we were using it in Kubernetes. In Kubernetes, you have what's called pods, and a pod is effectively that sender. So it would kind of be the smallest piece of work that you can do in your system. And you kind of, when you're designing a Kubernetes cluster, you do want to break up your responsibilities. You do want to try to separate your system into a lot of smaller workloads, because we can scale those workloads at a later stage. And I'll get into that in a little bit. The load balancer is a service on Kubernetes. So what a service does is it exposes the pods to the network. It kind of lets you send traffic to a pod. So what you do is you send traffic to a service. It will then automatically take that traffic and send it to the correct pod. And it will automatically load balance over those pods for you. So if you have 5 pods, it will make sure to send traffic over all 5 pods. If you have 100 pods, it will automatically send over 100. So it's very dynamic. So that's super useful, because now we don't have to install a load balancer, and we don't have to update it whenever we add more senders. Oh, do you want me?
But Docker Swarm can achieve this as well.
It is true. So I wouldn't say that there's a huge difference between Docker Swarm and Kubernetes and what they can achieve. Kubernetes is just what I'm talking about today. I won't say that because I don't have a lot of experience with it. So you speak from experience. Okay. So I'll tell you with Docker now, Kubernetes comes with Docker. So I think that they've kind of chosen Kubernetes as the... Yeah, exactly. I think everyone's kind of going in that direction now. But yeah. So Kubernetes uses labels. And when I first started using Kubernetes, I thought this was the dumbest thing ever. I didn't want to label everything that I had inside my cluster. But everything about Kubernetes uses labels. And labels are actually super, super powerful because they allow you to select things on a very granular level and a very coarse level as well. So if we take a pod, let's say you've got your normal email sender, you could label it as the app is mail comp, the type is a sender, and the environment is prod. Okay? You could also then have this new email sender that you're writing now, which does cool stuff and maybe is twice as fast, but it could be quite buggy. In this case, we would have the same label. It's part of the mail comp app. It's still a sender, but the environment is test. Okay? Now, the way that a service works is it uses labels to figure out which pods it should send traffic to. So if you just wanted to send to an email, the production email sender pod, you could just select pods that are of type sender and type prod. Then it will only go to your production level pods. If you wanted to send to your test environment, your test pod, you could select on a sender and environment test. And then you get the...
So essentially your services, which are load balancers, right?
Yeah.
Have to now load balance between your prod pods and your test pods.
No, they don't need to. I'm saying if I just select all type sender, then it would select both and it would load balance over both. But if you select type sender and prod, it will only ever send to the prod pods. If you have 100 prod pods, it will only send to the production pods. Even if you have 1,000 test pods. Yeah. So I'll give you an example of where this might be applicable, where you use a very coarse selector. You might have something where you've got something that processes data, and you've written it to be very fast for 8 pods. But you've got another 20 that are general that could do the same thing, but are 2 times slower. So what you do is with the service, you would select all pods that can do it. And you would pass traffic, but it would use the ones that are faster by default, and then pass to the slower ones. Well, those ones should have more load, so it would not pass to them as much. That's kind of when you would go for the more coarse selectors. Yeah. Okay, cool. So I'll get to the Ingress a little bit later, but Ingress then lets you also select what services to use, depending on what URL you're coming in from. So you could run multiple apps on your server. www.example.com could go into the first service, and then testing.example.com could go into the second service. So now you can, just by the URL you're going into, you can go into your a testing environment or an admin environment or your production environment, all of those things. So Kubernetes uses YAML as the kind of the language that they speak. It also uses JSON, but JSON is a little bit harder to read, especially with the configs that you use. So they've chosen YAML as the readable file, and I've taken this file for creating a pod and broken it into 2 parts. The first part is kind of the common language that's used for pretty much any Kubernetes object, and the second part is pod specific. So if we look at the first part, you've got your API version. Kubernetes is constantly changing, so you can specify which API to use, and that in turn determines what kind of language you can use inside that YAML file. Metadata is important. You give your pod a name, and you also give the labels, like I mentioned before. So you specify all of the labels that you want. You can have 1, you can have 100, you can have 1,000. It doesn't matter. On the right-hand side, the pod-specific stuff. You specify the Docker image that you're going to pull down. It doesn't only use Docker. There's some other container engines that Kubernetes uses as well. We just use Docker a lot. You specify the port inside the Docker container that you're going to send traffic to. And then 2 really cool concepts. You specify a liveness probe and a readiness probe. A readiness probe is something that is used by Kubernetes to determine when a pod is ready to start receiving traffic. So I don't know if you guys have had this before, but you might start up a Docker container or your server or whatever, and for the first 2 minutes, you get this failing. You try to start up your website and it says 500, the server's not working, or something like that. It's not ready yet. You could make it that the readiness probe only says true once all of the stuff is sorted and it's serving up that main page. Now, all of a sudden, when this pod is created, it will only say ready to receive traffic when it really is ready. The next thing is the liveness probe. A liveness probe can be used to make sure that a pod is still working. So it will check it every few seconds to see, is this pod still working? Is it still receiving traffic? Is it still happy? maybe a file corrupted or something like that on your server, or it's stuck in some process, and it shouldn't be running anymore. Kubernetes will automatically kill it, restart it, and now it will start up again. So the liveness probe is super, super useful. One of the really dumb mistakes that I made back in the day was that I linked my liveness probe to my database connection. So what I would do is I'd say, my backend system is ready when it can connect to the database. Oh, not ready, sorry, alive when it can connect to the database. So as soon as a connection failure happens with the database, my backend would also die. The problem with that is, now I don't get any logs. So if I was getting incoming traffic, I used to log everything so I could see that this traffic is coming in. Because the backend's dead, I don't get any logging and I don't have a database. So you got to be very careful with how you choose your liveness probes and your readiness probe. The readiness probe can depend on you being able to connect to the database, but the liveness probe should not. So just to point that, so a liveness probe should specify what determines whether or not that pod is ready to go, not whether or not all the other pods are working.
So can you just say it one more time?
Okay, so what I just said? Okay, so a readiness probe, you should check, am I connecting to the database? Am I able to open up files inside my system? Am I able to do all of the stuff that other things were providing to me? So am I able to query this website and all of that stuff? That's when it would be ready, when it's able to do all of that. A liveness probe should not check that sort of stuff because you might still want to receive traffic, because let's say my database shut down, okay? It doesn't mean that I want my backend to stop working completely. I actually still want it to run so I can log that traffic coming in, which I would maybe use at a later stage to rekindle that information and put it into the database. If I link that my backend system and my database are live together and only together, as soon as my database goes down, my backend goes down, and I get 4 or 500s or 404 not founds because now the backend system's not up. Cool. So that's creating a pod. A service is very much very similar to the pod. You specify the labels and a name, and then what's really important is the selector on a service. Those are the labels that are used to find the right pods to send traffic to. So these labels let you set how coarse or fine the pod selection is. And again, you specify the port that you want to connect to, and target port you can usually leave out, but what you could do is you can, on a service, say connect to port 12,000, and on my container or on the pod can take that and put it in port 9,000. So you can do port mappings, which is very useful.
So what other types of services?
You get load balancers and node ports are the main two. I actually don't know about the other ones. I haven't really read up about the other ones, but usually those are the two you would use. Yeah. Okay, cool. So a couple of commands. You've made these files. How do you actually start up a pod, and how do you start a service? You use kubectl, or Kubernetes control, and you just apply the YAML file, and that will start up the pod and the service. You can do a lot of other useful stuff. kubectl get pods shows you all of the pods that are running. kubectl get services shows you all of the services that you have. Tells you information about your IP addresses, your ports, all of that stuff. Describing a pod or describing a service gives you a lot of detail about that specific thing. It will tell you if it's running, it will tell you if it's healthy, it will tell you why it crashed, all of that stuff. You can get logs from pods, and then you can also just delete a pod, and that will completely kill that little container. So just having pods and services, you'd be able to build a cluster, and you'd actually be able to, from online, interface with that and start sending traffic to it, and it would respond, and you would have a little system. But there's a bit more to Kubernetes that makes it really powerful. A few things that I'll run through today, and there's way more than this, but a few things that will get you to a more advanced cluster is config maps, secrets, deployments, horizontal scalers, and Ingress. So I'm going to run through each one of them very briefly, just an example of what each one means. The first one is config maps. A config map can be a file or the environment variables that you want to bind into your pod. So before with Docker, you'd use a -e or -v. This is effectively those two commands. You can take a whole file and bind it in, or you can take variables and bind them in as environment variables. So config maps are super useful for just those config files that aren't a secret. They're just setups that you've maybe come up with. This is how my database is a lot faster. I chose 4,000 connections instead of 200 or whatever you do. Then secrets. Secrets are when the information is actually quite private, like your usernames and passwords. You would save them as a secret, and you can still bind them in to environmental variables or files or anything like that. You would save stuff like your SSH keys and your certificates and API tokens and stuff like that. Those would be saved as secrets on Kubernetes. Then deployments. Deployments are really cool. So we've looked at replica sets and stuff like that before at the previous talk. And a deployment is very similar to that. It actually runs a replica set in the background. But what a deployment does is it allows you to specify how many pods should be running. So you can say, I want my email sender and I want 100 of these pods to be running. And it will make, let's go with this example and just have 10. We've got 10 senders that are running. It will make 10 pods that are running, and it will try to ensure that 10 pods are always running. So if a pod dies, for example, it will start making a new pod straight away. So that pod it will remove and it will start putting a new pod in. You can also have something like, if you update to version 2, which we saw in the previous talk, if you update to version 2, you don't want to just delete everything that was version 1 and wait for version 2 to come up, because that could take 5 minutes or 10 minutes or whatever to start. So what a deployment does is it will run the old pods until new pods are ready. And it will, as soon as a new pod is ready, it will delete an old pod and replace it with a new pod. So you will have times where you've got both old and new pods running until all of the new pods are ready and all the old pods have been deleted. So it's really good for rolling updates because you don't have downtime between your version updates. And what we did see in the previous talk as well was that you can roll back. So you might find, oh, version 2 is not working well. You can just roll back to version 1. So it's really, really cool for that. A horizontal pod autoscaler just adds a bit more to that, because what it does is it allows you to change that replica's number. So it starts on 10, but you might say, I want a minimum of 1 sender and a maximum of 100 senders. And you can base it on metrics like the number of requests coming into my server per second, or the CPU usage of the pod. For example, if you have something that's processing the whole time, if it's at 100% CPU of its little CPU inside its pod, then it probably means that you want to make another one, and another one, and another one. So it will keep scaling up until it meets the criteria that you've set, or it meets that maximum, which is really, really awesome, because now we've got automatic scaling and resource handling. And then, sorry.
Make that sound as if there's CPU resources just assigned to a particular pod.
So you can make requests for a pod to use a certain amount of CPU usage. So you can say, for this pod, it shouldn't use more than 5% of the CPU that's actually on the system. So then, as soon as it starts using more than 5%, it will say, okay, it's over 100% usage. Now we should start another pod to share that load.
No, I'm not happy with that explanation.
Okay.
Because you don't have a certain amount of CPU resources put aside for a particular pod. It's using the system resources.
Yeah. So what I'm saying is, you expect a pod to only use 5% of your CPU, of a CPU on your system. And if it goes over that, so it can go over that. You're not saying limited to 5%. You're saying if it goes over that point, it would be more than 100% usage.
Where do you say that?
It's in the pod, like when you create a pod or when you create a deployment, you can specify the resource usage.
Okay.
I'll show a YAML file with that information. The resource request. Cool. So now you've got this little cluster that you've made. It automatically scales. From the cloud, you can hit the service, and you can. Yeah.
I just need to understand, when these pods are running, they would run at a certain port, right?
Yeah.
So then, if ever like now you're spawning a new one that was replacing the other one, how do you then know that? How do you tell it which port to use or whatever?
So you've specified which port the pod exposes, okay, to the service. And then whenever you create a pod, the way that Kubernetes works is it's got a virtual network. So a pod almost has its own, it's a mini virtual machine. So when it starts up, it's like its own computer that has that port available. and then the service will just say, cool, pass it to that pod, to that pod, to that pod. All of them would be on port 9000 or whatever you specified.
Okay, so everyone could run it.
Yeah, they have their own IP addresses because they're mini virtual machines, effectively, yeah. Cool.
You'd also probably allocate a wider port range than your actual set, so that a new one could be started and listen while when the old one is taken down, and then afterwards it could restart.
100%. It's got a whole IP range. Kubernetes has a whole IP subnet and range, which it would make all these pods in, so you can definitely do that. Okay, so you have one cluster, but that's cool, but you might want to have, let's say, 5 clusters or 10 clusters or whatever. And that's where we start seeing Ingress come into play. So in this case, what you can do is you can have from the first URL, it goes to the first service, the first cluster, or the service of that cluster. The second URL goes to the second one. And you can literally just specify different URLs going to different clusters. And what's cool about this is that Kubernetes allows you to set up HTTPS with Let's Encrypt. Well, there are libraries that do that for you. So automatically, you've got HTTPS on all of these domains, which is pretty useful, and it's good for testing and all of that stuff as well. Yeah.
Can you, instead of using Ingress, maybe use something like Nginx?
You could, but I think Ingress is a very good choice. Yeah, they have Google Cloud. Yeah, but they've written all of that stuff for you. So you're just saying, this is the URL that they must come in, and this is what services we must route to. Cool. And not only that, and this is where it gets really, really cool, is within Ingress, you can specify on subdomains and subpaths which service it should go to within that cluster. So you can say, if it comes in as /API, then it should go to my API service. And if it comes in as admin.example, it should go to this other service. And if it comes in as /dashboard, it should go to another service. So all of a sudden, we've got HTTPS, and we've got all of our routing sorted as well. So that's Ingress. Okay, so I've got a little example of a cluster of that sender. Okay, but now the horizontal scaler that I'm using is just based on CPU. It's not on requests per second. Can you guys not see this? Hold on. That's weird. It's like, I see it. Sorry?
Actually running 2 desktops.
Really? Okay, hold on a second. I am.
Not enough beer.
Okay, let's do this again. Multi-Chrome. No, I've got to cast to desktop, and I'll do that.
Yes.
Okay, cool.
There you go.
Okay, so if I get my pods, what it will do is it goes to Kubernetes and it shows you the pods that are running. Okay, so I'm going to just watch this and show that I just have one pod at the moment. Okay. Then I'm going to also follow the logs of this pod to show that it is actually receiving information. And I'll start posting to it now. And the final thing is, let me just, okay, the horizontal pod autoscaler is busy waiting for my pod's usage to be more than 30% of what I've allocated to it, of the CPU. So now what I'm going to do is start hitting it with a lot of traffic. So I'm starting to send, you need to send this email, you need to send this email. I'm going to keep doing that. I haven't done a lot of modifications to this server specifically. So it will take a little while. That's why we'll go through questions quickly. But effectively what's going to happen is over about 3 minutes, it will start scaling up because it's noticed that there's so much traffic coming in and so much CPU usage that's taking place that it will start assigning more and more pods to this sender until it starts sorting out that CPU problem. So I'll leave it on there. And then, do you want me to show you the deployment? Okay, cool. So you can see, sorry, just before we go, yeah, it's already started to create another 3 pods. And once those start up and start sharing the load, it will start creating more and more and more. And we'll just wait for this thing to scale up. And then 5 minutes later, when the traffic has all calmed down, it will scale down to 1 pod again. So it allows us to utilize resources really effectively. And the way that Google Cloud works is they charge you on CPU minutes. So if you have 100 senders running the whole time, that's going to cost you money. If you have one running the whole time until there's a high load of traffic, it's not going to cost you that much when the load comes in, and then it just calms down again. Okay, so I have no idea. I don't know how it chose 3. It may have just been. Let's just check what the. Yeah, I don't know, because the CPU usage is pretty high.
Was it at 120% maybe?
Yeah, it may be, but it was 1,200, so it's quite high. Okay, so for deployment, can you see this? Is it clear?
Can you switch the background to white?
How do you do that in?
No idea. Whatever edit you.
This is Visual Studio.
Anyway, if you
Color.
Yes.
Light. Okay.
there we go. Yeah.
So here we go. This is the resource that I'm. Okay, here we go.
So this is a deployment spec.
This is a deployment spec. So you can see here it's a deployment, and I'm pulling in a Docker image. Sorry. And here the resources are that I can allocate. So I can allocate memory and CPU resources to this pod, and it's not going to shut it down as soon as it reaches it, but it does. You can go over 100% usage. So I've now allocated 20 milli CPU to this pod. That means as soon as it goes over 20 milli CPUs, which then it will say you're running over 100%, and it would trigger the horizontal pod autoscaler. So it can use all of the resources on your system, but this metric is what's used by your horizontal autoscaler to determine when it's actually over that.
But that would still require you to do a lot of testing to determine what metric is best to decide whether or not you need to spin up a new pod.
Okay, so with CPU, yes. And I got a little bit lazy because with the new Kubernetes that they've just started releasing now, they've dropped Heapster, which is what they use for their metrics, and they're starting to do other stuff. With the new stuff, you can do requests per second coming in or packets per second going into your pod. So by that, you can actually calculate maybe with the 3-second sender, your request per second should only be 0.3. You know what I mean?
I have one other question just because I'm familiar with this.
Sure.
Can you have multiple host machines connected to this one Kubernetes setup so that it could theoretically spin up a pod on another machine?
Yes, and that's what's huge about Kubernetes. So one of the most awesome things about Kubernetes is the fact that it handles all of the networking and stuff for you. So you could start up a single node. You start up a second node. They connect to each other, share the tokens and all of the keys and everything. And now when you start up a pod, if you don't specify which node it should be on, it could be on either one of them. So what's really awesome about that is if this, let's say this competition just took off and it just became huge, and suddenly one node is just not enough, you could start a second node, and that would just start making more and more pods. And then when that one's not enough, it makes another node. And Google Cloud can actually scale up by nodes automatically for you as well. Yeah, so your cluster can automatically scale to whatever size you need.
You have 7 minutes left maximum.
Yeah, but I'm done.
Turn it off so we can set scale down.
Okay, that will take a while. That will take 5 minutes. Yeah, I'm getting. Okay, wait.
In theory, you're trying to use 120% of your CPUs.
Yes.
It logically scales that.
So yeah, so it then starts putting more pods in so that it can get to.
No, but you see the logic flaw. If your limit is 30% and it's scaled up to 3, it's 4 pods at maximum 30%. It's 120% CPU usage.
Yeah.
And it plans to scale to.
And then it started putting more and more and more. So the way that this thing works is it's got a 5-minute delay time. 3-minute delay time for upscaling, 5-minute for downscaling. So that means that it takes 3 minutes to then start scaling up and adding more pods. So I don't know what the way that they use for averaging and stuff to work out how many pods they need, but I'm sure I could change the limits to scale a lot larger. I saw another hand there. Or you?
I was just going to ask if that percentage is relative to the pod.
Yeah, that's to the pod. No.
But it kind of still works because it's sharing resources with one CPU.
Yes, it is, but it's like a percentage of a percentage. You know what I mean? It's 30% of 1%. Yeah, it is. Yeah.
What's to stop someone from being malicious and just hammering your server so it just starts?
Nothing. But that could happen on any server, right? Even on a normal server. And when someone does that to a normal server that doesn't auto-scale, it starts blocking up your threads and all of that stuff, and your server goes down. This effectively should fix that problem.
You'll have better warning if your server goes down and this one just keeps scaling.
Well, the warning only comes if you've actually written something that also looks at your server every few seconds or whatever and checks to see it's up, right? You could do the same with this, but you could also have stuff like alerts for requests coming in per second and stuff like that. So I actually think that with Kubernetes, firstly, you can alert yourself in time, and secondly, you can fix the problem before your site even goes down. So you could ban that IP, and at no point did anyone using your site experience 404 or 500 or anything like that.
Well, you will get a notification from your hosting provider.
Yeah.
Which is serve the customers.
So maybe I can help with the scaling question. So it's not really a question of how you scale. It's a question of how you fail. Do you understand what I mean? Yeah. It's like, there's a very simple deployment. You probably wouldn't need Kubernetes to do this. You've got simple use a language that has threads, and you don't need to. Don't use Node.js. This is not a good idea to do this. But if you've got a complex app with different parts of the app as different parts, you can now start to say, okay, this part, this is the shopping cart. It shouldn't go down. Back-end reporting, well, the accountants can stuff off and wait until tomorrow because I'm selling stuff right now. So that stuff is much more important. I want that stuff to scale more, and I can let that other part fail. If the guy gets his invoice email half an hour later, he's not going to freak out as long as he gets it. So that thing can and that thing's scaling parameters are much more flat. But the website handling the shopping baskets, that thing you scale like crazy.
So Takealot should have done that during Black Friday when they went down for the whole day. Were they? Maybe they chose the wrong pods to scale, eh?
They just didn't have enough hosts to run their scaling.
Yeah.
Well, they didn't work out how to scale fast.
Yeah.
In Amazon, in Amazon.com, there's a saying that even if the data center's on fire, you should still be able to take orders on the last remaining orders. Because that's what it's about.
Taking money.
But they didn't seem to know that when one person shut one down and they all shut down.
No testing, blah, blah, blah. You need proper SREs on board to do that kind of stuff. But essentially, that's, to my mind, that's the way I would think about it. So, yes, of course, I've got a shoebox of hardware. That's how much I can put in it. Right? And something's going, especially if I start, it goes crazy viral on Facebook and I'm getting hit and I'm starting to die. I can now start to make intelligent choices about how I die.
But I also think one of the really important things to think about now is just when you're developing an application, think about how you're going to break up that system into different pods and everything, because it allows you to almost develop a fully scalable solution. It might be small now, but 3 years down the line, it might grow to something that's quite significant. And instead of having to rewrite the system or reinstall the server or whatever, it could just be on a Kubernetes cluster. You connect it to a new node and you're scaling. You know what I mean? So I think that's also really...
Yeah, but it's very different if you think about which parts of your stack can die.
Yeah.
We can talk a little bit just now about the history of Kubernetes and where it comes from, what its kind of design ideas, if you guys want.
Okay, I know that you said the example here, you said it's very simplistic, and it's a very, in my mind, a reactive auto-scaling solution because you suddenly get the load. How would you kind of set it up? Let's say I run a company whereby on the 25th and the 1st of the month, I suddenly get an influx, and I'd rather be, yes, you want still the capability to scale, but you kind of have enough data to inform that decision-making already. How does that fit into
with Kubernetes, I don't know if there's like a scaler that you can set a date and it will scale up, but with a deployment, you can just set the replicas to be 100 on those times and then turn it down later if you wanted to. So you can manually also auto-scale it up and then, manually scale it up and then scale it down at a later stage if you wanted to. It's very easy to do that. You just set the number of replicas to 100. One command line and you're done. So I guess if you knew those dates were the specific dates, you could set up a cron job to do it and then run,
What is pending?
Okay, so pending is when it's not running yet. So it's kind of, it started up, the container's running, but you know how we have like liveness probes and readiness probes? Readiness probe hasn't been met yet. It doesn't think it can receive traffic yet.
It's not one that shut down and it's just waiting for a while before it really decides.
No, that would say terminating. So I'll show you, I can kill one.
Stop your load, you'll see.
I think I have. Yeah, you see. Yeah, I think I have.
So with Kubernetes, can you also do like bar mounts like Docker?
Sorry, what?
Can you also mount like Docker?
Yes, so that config map and
Okay, so because so what if you've got a pod, right? And then let's say you mount your documents folder, and then that pod, after a certain amount of time, wants to scale up. And then if it scales up by 3 more pods, and you've mounted the first pod to your documents, if maybe the first one now is using maybe a file inside it, like your daemon or whatever, the second one that actually wants to start up, obviously it'll probably use the same configuration as the first one.
Yeah.
It'll also come up and also mount your documents. So then won't there be errors saying that the daemon is probably locked by the...
Okay, so mounting a document I think is a bit different. So you can mount directories, you can have a database directory. Okay, so so you probably shouldn't have multiple database instances running on the same directory unless the database actually supports that. So for example, Postgres doesn't. So you would only have one Postgres pod if you had a Postgres pod. I don't know if there are any databases that do support multiple. Which one? Mongo. So you
actually shouldn't be using the loopback storage driver. You should use like the LVM driver or something, and then any pod that has containers that needs persistent storage should be using that.
Yeah, so you use PV and PVC. Yeah.
More with their solution, like friends shouldn't let friends run loopback.
That's right. So it's called PV and persistent volume and persistent volume claims.
Persistent volume claim can be using the loopback storage driver, which is just a native file system.
Yeah.
But there's like a driver for LVM. I think there's one for Ceph. There's a whole bunch.
Yeah. But then you need to also keep in mind the pod that you're running. There's a system behind it, and if that can support multiple things accessing the same file, that's fine, but if it can't, then you shouldn't be doing it. So like, for example, queuing systems can. If you have a queuing system, you can mount that same file, and then if the queuing systems die and a new one starts up, it will know what's still in the queue. But for a database, maybe that's not the best idea.
I'm assuming like of the swarm, the orchestrator enables cross-platform clusters.
I don't know. That Docker Swarm.
So now you can
Well, Docker's Linux, right? Let's just be clear here. I mean, all they're doing in Windows is emulating the Linux kernel API with the Windows Linux subsystem.
We can go into a big debate about that.
Sorry?
We can go into a big debate about that.
No, that's all it is. I mean, there's a way of looking at Docker that it's just C groups of Linux, right? Yeah. That's all it is. There's no, you have a shared kernel model.
Well, the question still remains, does Kubernetes support cross-platform deployment?
No.
It does, but you have to have cross-deployment. You have to have minions, right? So you can't run, like I said, you can't run a Linux container on Windows unless you're doing something super.
So one of the guys at Cloud Africa, he's like a Raspberry Pi now.
Yes.
Awesome. He's got Docker running up on these Raspberry Pis. He's like, crap, there are no images available for the ARM architecture. It's like, what do you mean there's no Postgres?
Well, I'm saying the Docker Swarm, for example, the same cluster, the same swarm. You can have Windows nodes, Linux nodes, servers running, and it manages the single.
You're talking about the physical hosts, the underlying hosts.
And
sure.
The images have to be matched.
You can bring up anything that supports the Linux API. That's fine. That's what they do under XIve on macOS.
I'm talking cross-platform. I'm talking running on multiple different platforms.
Underlying operating system. Yeah. Any more questions, Kerren? We go into the next phase.
Cool. Thank you.
Thank you very much.